Okay, in this video I'm going to talk about the angle intersecting a circle with the vertex outside of the circle. So basically we have a circle like this. We have an angle. So this is the vertex of the angle, and let's say that it intersects the circle like this. And now the problem is how to express the angle in terms of the arcs of the circle that it cuts from the circle. So from these two arcs. And so basically the main statement, the main theorem that I'm going to discuss today is that, so like if we denote, let's say this point would be A, B, C, D, and the angle let it be P. So the main statement is that the angle CPD, or like maybe it's easier to write just angle P. So angle P is equal to one half of the difference of the arcs. So the arc AP minus the arc CD. Yeah, so that's the main statement. So let's prove it. So basically the main idea is to draw a parallel line. So let's say from the point C we draw a parallel line to BD, to the other line of the angle. Excuse me, it's not parallel. Yeah, something like this. So until it intersects the circle in the point, let's call it, I don't know, E. So let's increase this. Yeah, so this is the point E. So we know from another theorem that parallel lines, yeah, so let's write here that CE is parallel to BD, right? So we know that the parallel lines cut the the arcs, like the equal arcs on the circle. So like if we have a circle and we have two parallel lines, then these arcs are the same. So this is a separate theorem, and I made a separate video about this. I gave a proof of this. So we are going to use this here. So using this theorem, so from these parallel lines we conclude that the arc CD is equal to the arc EB, right? So this arc is equal to this arc. Yeah, and so now now we notice that because the lines are parallel, because these lines are parallel, another conclusion is that the angle P that we need to find is equal also to the angle ECA, right? So in this picture, like this angle is equal to this angle, right? So yeah, maybe it was worth to draw a larger picture, but anyway, so from these angles, and also now this angle ECA, it's an inscribed angle, so this is inscribed angle, and it is equal to half of the arc which it subtends, so half of the arc AE, right? So now the arc AE is equal to, so the arc AE is equal to, we express this arc as the difference between BA minus EB. So AB minus the arc EB, right? Okay, let's write this more carefully. Yeah, the arc EB. And this is equal to, so AB we leave it as it is, and EB we rewrite using this equality that we obtained previously. So we write that this is 1/2 of AB minus CD, the arc CD. And this is actually exactly what we need to obtain. So like we look at the beginning, so the angle P is equal, then the chain of equalities, and the look at the end, 1/2 of the difference between the arcs AB and CD, and this is exactly what we need to prove. So this concludes the proof.